A very good morning, dear students. Today we are going to learn about the concept of uh, thermosetting plastics with its examples. So let us start with the main example of thermosetting plastic, that is Bakelite. So Bakelite is the first synthetic polymer, and Bakelite is also known as a phenol formaldehyde resin, and it is prepared from the monomers called phenol and formaldehyde, and it is also known as phenoplast. And bakelite, a phenol formaldehyde resin or a polymer, which was the first completely synthetic plastic. It was first made by Leo Baekeland in the year of 1907, and Baekeland and an assistant started their research in 1904 looking for a synthetic substitute for shellac. And bakelite was commercially introduced in 1909. Bakelite was first used to make billiard balls, but later was used to make molded insulation, valve parts, knobs, buttons, knife handles, many type of molded plastic container for radios and electronic instruments, and many more. And after that we have the preparation of bakelite. So in order to prepare bakelite, the reactants or the monomers that are undergoing condensation polymerization are phenol and formaldehyde. So in order to prepare bakelite, we have a method of preparation. Here phenol formaldehyde polymers are the oldest synthetic polymers, and these are obtained by the condensation polymerization of phenol with formaldehyde in the presence of either acid or base catalyst. And the reaction starts with the initial formation of a orthohydroxymethylphenol or parahydroxymethylphenol, which further reacts with phenol to form the linear chain polymer that is called novolac, which consists of the very important uh, benzene ring systems which are joined together by CH2 groups. So let us have the preparation of this one, novolac. After preparation of novolac, which on heating with the substance called uh, hexamethylene tetramine, which produces two important components: number one, formaldehyde, and number two, ammonia. So the formaldehyde, which on reaction with novolac undergoes cross linking to form an infusible solid mass, which is called bakelite. And we can see that the very important chemical reaction that is involved in the formation of a cross-linked solid bakelite from phenol and formaldehyde. First, C6H5OH plus CH2 double bond O. So phenol plus formaldehyde gives rise to, so which is giving rise to the formation of orthohydroxymethylphenol or parahydroxymethylphenol. For example, if three molecules of formaldehyde that reacts with phenol, then it gives rise to the formation of trihydroxymethylphenol. Therefore, the formed trihydroxymethylphenol, so which on heating, which undergoes dehydration process and gives rise to the formation of an intermediate, reactive intermediate, and further it reacts with phenol and gives rise to the formation of novolac, which is a long linear chain polymer of this bakelite. And here even we can take orthohydroxymethylphenol, which undergoes condensation polymerization with a phenol and gives rise to the formation of a long linear chain polymer called novolac. And hence in the next step the formed novolac reacts with which reacts with hexamethylene tetramine and which produces two components. One is called formaldehyde. The obtained formaldehyde which reacts with novolac and gives rise to the formation of the a cross-linked bakelite, so which is the main important plastic, thermosetting plastic. And even the hexamethylene tetramine also produces the second compound, that is called ammonia. So here ammonia is used in neutralizing the acid catalyst. Okay, so this is the preparation method of bakelite. And coming to the next important point, that is properties of bakelite. So there are very important properties of bakelite. Bakelite consists of a hard, rigid, scratch resistant, infusible, water resistant, insoluble solid kind of material, and it is resistant to non-oxidizing acids, salts, and many organic solvents. So here the bakelite, which consists of acidic OH groups, that is phenolic OH groups, which are weakly acidic, therefore they are easily attacked by alkalis. So therefore, they show good resistance to acids and solvents as well as salts, but they are easily attacked by the alkalis, that is bases. So here they possess excellent electrical insulating characteristic property, that is one of the important property of the bakelite. And now we are moving on to the so-called uses of bakelite. So there are many number of uses of bakelite in our day-to-day life we observe. So number one, these are the thermosetting plastics which are mainly used in the manufacturing of telephone handles, heater handles, TV parts, TV cabinets, radio parts. Next, they're also used in phonograph records. Next, the third point, they are also used in electrical switches and bearings used in propeller shafts in paper industry. And next, they are used for soft bakelite, as like they are used as binder glue for laminated wooden paints and in varnishes. And the next important use is the sulfonated bakelite, which are used as ion exchange resins. And even the next point, they are also used for impregnating fabrics, wood and paper. So these are the very important applications or uses of bakelite, and we can see it in the picture. There is a phonograph records, valves, knobs, buttons, and some of the important bakelite derivatives. Next, we will have the next important concept after bakelite, which is the next thermosetting plastic we are going to study is nylons. So nylons are the very important kind of polymers, which we also call them as polyamides. So nylons are categorized into three types depending on the number of carbon atoms. So nylon is used as a general name for all synthetic fibers forming polyamides. So here they are having a protein-like structure, and these are formed by condensation polymerization. And here the condensation polymerization of diamines and dibasic acids, which undergoes the process of condensation polymerization and gives rise to nylons. Those are called polyamides. And a number of different types of nylons are present depending on the number of carbon atoms. So here we have the first one, that is called nylon 6,6. So here nylon 6,6, which is obtained, excuse me, nylon 6,6 is obtained by the polymerization of adipic acid with hexamethylene diamine. Here adipic acid is represented as COOH, CH2 taken 4 times, COOH plus hexamethylene diamine, which is represented as NH2, CH2 taken 6 times, NH2. And by the loss of H2O, so there is a formation of amide, that is C double bond O, CH2 taken 4, CO, C double bond O, NH, CH2 taken 6 times, NH taken N. This is the method of preparation of nylon 6,6. This is also called polyhexamethylene adipate. So next we have the second important type of nylon of the group of nylons, that is nylon 6. So nylon 6 molecule is prepared and it is produced by the self condensation polymerization of caprolactam. So here there is a cyclohexanone, so the initial molecule which undergoes reaction with NH2OH. So on Beckmann rearrangement, we will get cyclohexanoxime, cyclohexanoxime. After that, the very important here, there is a NOH that is get substituted in the place of O, that results in cyclohexanoxime, and which undergoes chemical reaction with sulfuric acid, and there is a ring opening reaction, and 6-membered ring is converted into a 7-membered ring system having 6 carbons and 1 hetero atom, that is nitrogen, and this gives you a C double bond O NH group. So this is called caprolactam. The formed caprolactam, which is undergoing the self condensation polymerization by the ring opening reaction, and gives rise to the formation of COOH, CH2 taken 5, NH, CO, C2H, CH2 taken 5, NH2, and finally it is undergoing the loss of water. So here by the loss of water, so it will be converted into a very important nylon 6 molecule, that is C double bond O, CH2 taken 5, NH taken N times. So this is the method of preparation of nylon 6 molecule. And one more important type of nylon is there, that is nylon 11, which is obtained from the chemical reaction of omega amino undecanoic acid. So here omega amino undecanoic acid, which is represented as like, so C double bond OOH, CH2 taken 10 times, NH2, which undergoes self condensation polymerization and gives rise to the formation of a very important product, that is C double bond O, CH2 taken 10 times, NH taken N times. This is nylon 11 molecule. And let us move on to the properties of nylon. So you see the properties of the nylons. So they have a very important characteristic properties, like they are translucent, whitish, horny, and having high melting points, and they possess high temperature stability and as well as high abrasion resistance. And the third important property is they are insoluble in almost all common organic solvents, but it is soluble in phenol and formic acid. So this is soluble in phenol and formic acid. So it is insoluble in almost all common organic solvents like spirit, benzene, acetone, and etc. But it is soluble in phenol and formic acid. So their molding and extrusions have good physical strengths, especially high impact strength and self-lubricating properties. So let us have the next important characteristics of nylon. They are light, horny, and high melting points. They are insoluble in common solvents. They have good strength. They absorb little moisture, and thus they show drip dry in nature, and they are very flexible, and they retain their original shape after use, and they are resistant to abrasion, and even they are on blending with wool, the strength and abrasion resistance of the later gets increased. So let us have some of the important applications or uses of nylons. So nylon 6,6 is primarily used for fibers, which finds use in making socks, so ladies hoses, dresses, carpets, etc. Nylon 6 is mainly used for molding purposes, for gears, bearings, electrical mountings, and these bearings and gears work quietly without any lubrication. And they are also used for making filaments for ropes, bristles for toothbrushes, and films, tire cords. These are the main uses of the nylons. Okay, next we have the silicones. Let us have the silicone polymers. Okay, so while we are going to learn about silicone polymers are a very important type of polymers which are called inorganic polymers. And these silicone polymers, they do not have carbon as a part of the backbone, but in the place of the carbon group element called silicon is present, and this silicon can have the same properties as like carbon, like catenation, tetravalency, and so on. Like the silicon can make a bond with another silicon as well. Even it can form a bond with oxygen also. So there are some important bonds, and these are represented as silicon bonds in the case of silanes, which are very much analogous to hydrocarbons, and these compounds are not very stable, and hence they are not very useful. And silicones on the other side, they have hard, they are having good typical structure, and here the very important structural unit is found in many type of minerals, rocks, and even in the case of sand. Various organic groups such as methyl or benzene ring may be bonded to the silicon, and we can see it in the picture, the schematic diagram representing silicon oxygen long chain, and the side groups that are represented as like R, and these R groups may be methyl, phenyl, or any kind of a group it is. So now even it may be, even it can be any alkyl group or aryl group. After this we have the silicon polymer uses. So silicon polymer has some very important uses. They are water repellent, heat stable, and very resistant to chemical attack. And they find many uses in oils, greases, and rubber like materials. And silicone oils are very desirable since they do not decompose at high temperature and do not become viscous. And other silicones are used in hydraulic fluids, electrical insulators, and moisture proofing agents in fabrics. And silicones have a number of medical applications because they are commercially inert. A good deal of controversy has involved the use of silicone in polyurethane bags as the very important type of implants. Again, there were the use of these silicone polymers in so many important type of chemical reactions, and they are with reports that have cited increased cancer risk, and they serve immune responses from possible leakage of silicone from the implants. Okay, this is about the silicone polymer. Okay, so in this class we have learned about the bakelite, nylons and silicone polymers. Hope you all understood today's class. Thank you.